Hi, welcome to Statistics Online. I'm Naomi Lowe, and today we are ready for lecture number 2. Today in lecture number 2, we will be covering two things: measures of central tendency, the mean, median, and mode. Central tendency refers to where most of your data falls. It's not always in the center, but it's where the majority of your data lies. And then we will look at measures of spread, how spread out your data is. It's also known as a variability. Two common measures of spread or variability are the variance and standard deviation, and you will learn how to calculate each of these items. Okay, first we have the mean, the angriest statistic. The mean is an average. It's a simple average. You've probably all learned how to calculate this, and this is your first formula. Don't let it scare you. This formula is really simple as long as you understand some notation. In statistics, you are going to find a lot of notation, characters that mean something, which are useful because if we had to write everything out longhand, we would be here for days and you'd have to read a whole lot, where you can just use a little symbol and it's meaningful to you. So let me explain some of these symbols. N represents the total number in a sample. So it's the number of people you're analyzing, the number of scores you're analyzing. If you were working with plants, it'd be the number of plants you are analyzing, but that's the total number in your sample. Okay? And M is typically the mean, so that's easy enough to remember. In psychology, they often use M for the mean or X bar. Okay? X bar. You'll see X bar in mathematics, so it's important to know the notations for different fields, because when you're reading literature, it won't always be the same. So the book uses M, but X bar means the same thing as mean. Okay? Now, this X is just, it represents a score or a variable. So X could represent how stressed out students are. Remember from the last lecture, there was a score from 0 to 10. X represents stress scores. It just represents the variable of interest, the scores from 0 to 10. This part of the formula is a symbol that means add or sum everything that follows it. It's really easy to remember. It kind of looks like the mouth of a hungry alligator. And so I just remember, the hungry alligator eats everything in front of it. You sum everything that comes after that hungry alligator. So this formula now shouldn't be so scary. It just means the mean, M or X bar, is to add up or sum all of the scores of this variable. For example, stress ratings. You sum every single score, and then you divide by N, the total number of scores you have. Pretty simple. Same thing as your average, your mean. Add up all the scores and divide by the number of scores you have. Easy enough. Let's try it. Here we have the number of dreams that people reported having in the past week. So the number of dreams, this person had 7 dreams, the next person had 8 dreams, and so forth. So go ahead and try to calculate the mean or the average of these dreams. Remember, the first step in this formula is to sum all of the scores. All of the X represents dreams now. It just represents the variable. So sum all of the scores, 7 plus 8 plus 8 plus 7. Add those all up. You should get 60. The sum of every score, the variables, and sometimes you'll see a little I on this formula. The I just means all of the numbers of this variable. And so you sum all of the numbers of this variable, you get 60 total. Now, in order to get the average, the last step of this formula is to divide by N. How many numbers do you have here? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 students reported how many dreams they had. So guess what we're going to divide 60 by? 10. N equals 10. 60 divided by 10 equals 6. And 6 is your mean or your average. 6 is your average, your mean. So the average number of dreams that these 10 students had in the past week was 6. It tells us something about where most of the data falls. It means most of the students had around 6. Now, it doesn't mean exactly 6. It could be slightly above, slightly below, but most of the data centers around 6. All right, perfect. You might want to go through your homework, try a few more, calculate the mean, not too difficult. Oh, I made a little note here so I wouldn't forget my statistics jokes. I'm sure you're holding your breath. My first joke is about the statistician who said he had his head in the freezer and his feet in the oven, but on average, he felt just fine. The other joke about the mean was about the statistician who drowned in a river with an average or a mean height of water that was only 2 feet. If you don't get that one, the average, so you add the highs and the lows and come up with the middle ground. You could have really low amounts of water in part of the river and really high amounts in a different part of the river. You average them, you're going to get somewhere in the middle because you're adding all of the scores in and dividing by the total number of measurements. You could get an average of 2 feet, which obviously would be a little difficult to drown in. All right, let's move on to the next measure of central tendency, which is the median. Now, the median is different than the mean because the median is the middlemost number. Okay? So instead of adding all of the numbers, you just line up all of your scores from smallest to largest, and you count in to the very middle score, and that is your median. Now, there are some times when you want to use a median instead of a mean. The reason you would use a median instead of a mean is because you might have extreme scores that if you calculated a mean and you had a really extreme score, it would bring that average or the mean up. And so say you were interested in buying a house and you want to know how much houses in a certain neighborhood run. And you go to the neighborhood, you go, oh, it's a nice neighborhood. I wonder what that mean price of houses in this neighborhood is. Now, if you've ever looked in the newspaper, they do not list mean price of house for neighborhoods. They list median. Because if you used a mean, you would put all of the prices of houses in that neighborhood, including what if there's a big, huge mansion? There's one big, huge mansion. That goes into calculating the mean. You add that in there, what's going to happen to your mean? It's going to look higher than it really is. And you go, oh, wow, these houses are too much. I can't afford them. But what you really want to know is what's like the middle most price of the house? What are normal prices? What's the normal range in the middle of those houses? So a median would be a more appropriate statistic to use. Check next time you're looking at the newspaper. They use it for house prices. So here, you just arrange the numbers from lowest to highest, and then you count into the middle score. If you have an even amount of numbers, you will not have a middle score. You will have 2 middle scores, and you have to just take the average of those 2 scores. So go ahead and try it. Take the median of these scores. We have these scores that we just looked at for the mean. So what's our first step? You need to put them in order. They're not in order of lowest to smallest. They start 7, 8. They kind of bounce around. So put them in order. Start with 1, 3, 3, 6, 7, 7, 8, 8, 8, and 9. And then you would just count in. Here's the outside number, 2, 3, 4, and now look, you have 2 numbers in the middle because we have 10 numbers, so we have 2 middle numbers. Now here they're the same number, so you don't really have to worry about it. The same number, if you average a 7 and a 7, 7 plus 7, remember we just did the mean, divided by 2 is 7, so you're perfectly fine. But had they been different numbers, you would have needed to average them and it would be in between the 2, okay? So go ahead and tell me what the median is here. The middlemost number, the average of these 2, and your median here equals 7. Okay, so it's another measure of central tendency. The median is the average of the mean of the middle 2 numbers, and so here our median is 7. Hopefully that's clear. Let's move on to our third measure of central tendency. Sorry, I don't have any median jokes. If you think of any, email them to me. All right. Now the mode is just the most common single number in a set of scores. Okay. So we talked in the first lecture a little bit excuse me, about modes, and we were talking about the majority of data on a histogram. This is different. This is the calculated mode. It's the most frequently occurring score. So here, the mode is the most common single number in a distribution. Here, if you look at the numbers and you count how many 7s we have 1, 2 7s. Okay? If you count how many 8s we have, 1, 2, 3 8s. So there are more 8s than 7s, so that would be eliminated. Are there more than only 2 3s, only 1 1? So our mode here, 8 is the number that occurs most frequently. That is our mode. Now, this is a good measure of central tendency for nominal variables because if you have something like hair color, all you can do is count and go, okay, the mode would be brunette. That means it's the most common hair color. So mode is a really good option for nominal variables. Median and mean do not work for nominal variables, so keep that in mind. Now, with the mode, if you have no numbers that occur more than once, so all of the numbers in your set only occur once, there's not duplicates of them, you do not have a mode. And if you have numbers that occur at the same time as other numbers, so say that we had 4 7s and 4 8s, and those were the two most frequently occurring scores, you would have two modes. Okay, so you would have a mode that was 7 and a mode that was 8. So you can have multiple modes or no mode in a set of data. Now, a mode would not be a good option for a continuous variable because if we were looking at height and we measured it in centimeters, just because two people happen to be the exact same number of centimeters or inches tall, that's not real meaningful. It's more meaningful to look at groups of data with continuous variables. So an average or a mean would be a better use of central tendency when we're using continuous data. All right, now I just want to compare the mean and the median. The mean is going to be a very commonly used statistic when we move on to doing tests. It's very important to know. The median is good to know too. It's a little bit less frequently used, but I want to compare the two. The mean, you know how to calculate. Every single score contributes to the mean. But the median, does every score necessarily contribute its value to the median? You just line them up and pick the middle score. Let's take this for example. 1, 2, and 3, these numbers. If we were to take the mean of these numbers, you'd add 3 plus 2 plus 1, 6, divide by 3, and your average is 2. So here's our average. Okay. Now, if you were to take the median, outside number, move to the inside, 2 is also your median. Now let's change this just a little bit. Okay. Let's change this up a little bit. Instead of 3, let's say someone scored really high. You had a 1, a 2, and 10,000 was your third score. Okay. Now your average, if you calculate the average of this, so add up your average or your mean, same thing, plus 2 plus 1 equals, and then remember we divide by 3. Your average is now a really high number. It's over 3,000. So your average is 3,334. This is your new average. What about the median with this new set of data? How do we calculate the median? You just go from the outside to the inside. Guess what? Your median is still 2. So did this extreme score affect your mean? Yes. Did it affect your median? No. So this is important to remember that when you have extreme scores, they are going to affect your mean, but they are not going to affect your median. Now, when we're talking about distributions, this is also important to remember because if you have a distribution that looks like this, remember back to the histograms, and your mean somewhere in here, okay? Your median is probably going to be similar to that mean if you have a symmetrical set of data. Okay? But if you have some extreme scores up here, now remember, if you have extreme scores up on this end, what is your distribution going to look like? It's not going to be symmetrical like this. It's now what we call these extreme scores up here. What type of skew is this? You should remember this. This is right skewed or positively skewed. Now these extreme scores, they go into, remember your mean was, before you had these extreme scores, your mean's down here somewhere. But those extreme scores, you add them into your mean, and what's going to happen to your mean? You add really high numbers into your mean, which direction is your mean going to shift? It goes this direction. So now your new mean might be somewhere like this, your new mean. Okay? But your median is still down here. It doesn't move. So when you change a distribution from being symmetrical to having extreme values, so if you add in some extreme values, your mean shifts over here, but your median does not shift. Okay. So if I just told you I had two scores, I had a mean of 50 and a median of 25, you wouldn't even have to see this data set. You would automatically know, oh, the mean is higher than the median. You must have outliers that are high or to the right, and you would know this distribution has a positive skew. Now, if I gave you the opposite scenario, if I said that the mean was 25 and the median 50, that means that your mean is lower than your median. And if your mean is lower than your median, so the mean is down here, you know it's being pulled by extreme scores that are small. So in this case, if those extreme scores are small, but most of your data is on this side, you have your mean is lower, your median's still up here, you know that you have a left skewed variable. Okay? So left skewed, not symmetrical. So when the mean and median are equal, your data is symmetrical. Make sense? Okay. Now we are going to look at some measures of spread or variability. Now when I say measures of spread, I'm going to give you some examples. If I have a data set, a histogram, remember these are representing histograms, and the data set looks like this. Okay? So let's say this is exam scores, my past exam scores for students. That means, here's 0, here's 100%. It means most students scored somewhere around here 50, and some scored lower and higher. There was a whole range of frequencies. Okay? But suppose that I show you the distribution, and it's centered around the same number, but it looks like this. This means that most of my students scored around 50, hardly any of them scored 100 or 0, where before you have quite a few scoring 100 or 0. So this one, the scores are more spread out than this one. We call that variance. The scores vary more with this first example than they do with the second example. I could give you a different distribution. Would you rather be in a class with scores like this, or a class with scores like this? You get to choose. Do you want the class that has them spread out, or the class that has them really tightly together? This has high variance, this has small variance, or variability in the scores. So I would choose this class. If you knew that the exam scores in my class looked like that, and some other professor had exam scores like the top distribution, you would probably go for the instructor that has less variability in their student scores, that most of their student scores center around 100% or around a good score on the exam. So that's just a conceptual way of thinking about how spread out the scores are. Now there are two different terms that we use for measures of spread. There are several, but the two main ones are standard deviation and variance. So instead of just saying, oh, it's really spread out or it's hardly spread out at all, I'm going to give a number that represents how spread out this is. Now, if you keep in mind, the bigger the number, the larger the number, the more spread out the data set, then that's really great, okay, for both variance and standard deviation. So first, we are going to talk about variance, because the way that variance works, standard deviation is the square root of variance, and variance is standard deviation squared. Here we have another formula. Don't let it be daunting to you. It's very simple to understand, just as the formula for the mean was. So here, the measures of variability. First, let me talk, if you see here, SD stands for standard deviation. SD squared, this is standard deviation, SD squared equals, you should know this, I just told you, variance. So they're the same thing. If you take SD squared and you take the square root of that, what happens? It just becomes standard deviation. So this is something you should have down. Standard deviation, variance. Standard deviation squared is variance. Square root of variance is standard deviation. Those are the relationships between the two. Let me talk for a minute just about standard deviation in general. Standard deviation conceptually is like an average of how far scores are spread from the mean. So in order to calculate standard deviation, first you need the mean. Okay? Then you need to know how far are all of your scores from the mean. So the example I gave you before, I had 1, 2, and 3 as our numbers. So the mean of 1, 2, and 3 is 2. Then I want to know how far are the numbers spread out. How far, the mean is 2. How far is 1 from 2? It's only 1 away. How far is 3 from 2? It's only 1 away. So on average, all of the scores, except for the 1, 2, are 1 point away from the mean. And then the mean itself is 0 points away from the mean too. So you would have to add 1 plus 0 and divide them. So that gives you kind of an average of how far the scores are spread away from the mean. Now if you got a larger number, if I told you the standard deviation or the average of scores, how far they deviate from the mean, was 20. You know that I don't have a 1, 2, and a 3 because on average, the scores spread out 20 points away from whatever that mean is. Okay. Now, in order to calculate standard deviation, we do have to calculate variance first. And here is why. Okay. If you have 3 numbers, 1, 2, and 3, the way you would calculate standard deviation is to take the score and subtract the mean. So you take 1, that's the first score, subtract the mean, 2. And if you do that, you're going to get -1. And you would do that with each of these scores. So 2 minus 2 equals 0. And then 3 minus 2 equals +1. Now if you look here, we have a -1 and a +1. Because the mean is a measure of central tendency, it's always going to be in the middle. So what happens if we add all these scores? Those are the deviations from the mean. It's telling you how far those scores are from the mean. Now if we want to add them up to get an average, what happens? We add -1, 0, and +1. Obviously, you add these up, you end up with 0. That doesn't work. Is the distance from the mean really 0? No. But if you take both sides, the positive and the negative, you're going to end up with 0 every single time. So instead of doing this, we take these differences or deviations from the mean and we square them. When you square a number, you get rid of the negative sign. And so now you have squared, so here in this formula, the score minus the mean. Sometimes you will see it written x minus x bar. Same thing, squared. So it's saying take every score, subtract the mean, square it, and then once you've done that with every score in your data set, you do what? With the hungry alligator, you add them all up. So you would add them all up, 1 plus 0 plus 1, 1 squared is 1, so you end up with 2. We call that the sum of squares. The sum, it's the sum of squared deviations from the mean, also noted as SS. Sum of squared deviations from the mean is this part of the equation. Added up all the deviations from the mean squared. Here it happens to be 2. And then to get an average of those, you divide by n. So here we only have 3 numbers. You would divide 2 by 3. And you get 0.66. So you're dividing this top sum of squared deviations, which we got, the deviations squared, -1 squared plus 0 squared plus 1 squared. Add them up. It's 2, divide by 3, or n, and you get 0.66. Congratulations, that is your variance. Your variance. Okay. Now variance can be written SD squared. It can also be written sigma squared. Okay. So many times this is what we write for variance of a population. I will explain later how we can calculate variance of a sample. This also represents variance of a sample. So all of these are synonymous symbols for variance. So guess what the symbols are for standard deviation? Just get rid of the square and it's standard deviation. So guess what we have to do to this variance to calculate standard deviation? Very easy. You just take the square root of the variance and voila, you have standard deviation. Now why do we take the square root of the variance for standard deviation? The reason we take the square root of the variance, because remember when we were going to add up how far all the scores are from the mean, we had to square them so that they didn't end up being 0. So we square them. So our variance is this measure of how far they are squared, the average of how far the squared deviations are. But it's not real meaningful for our original units. So we go back to our original units by taking the square root, and then it's meaningful in these original units that we started working with. Remember, these numbers are always representing something in real life. So maybe this 1 and the 2 and 3 represents how many dreams 3 different students had last week. So those numbers, if we said, oh, the variance is 0.66, that it would spread out about 0.66, but that's squared. So it's hard for us in our brains to take the square root of that. So you just do it by hand, take the square root of it, and that is your standard deviation. So just so that you have them, these are the steps for calculating variance. The first step, you have to find the average and the mean. You need that first. Then you need to subtract the mean from each score. So each score minus the mean. Okay, simple enough. If it's a positive number you get here, it means that your score was above the mean. If it's a negative number you get, it means your score was below the mean. Then you square each of these deviations. You square them all. And you square them because you don't want to end up adding them all up and coming to 0 each time. After you square them, you add them up. You get the sums of squared deviations. And you divide the sum of squared deviations by the number of scores you have there. This is your variance. Now, if you want to change your variance into standard deviation is more popularly reported in statistical literature, in research, because it's understandable in the measure of units that you're originally working with. So all you do is take your variance and then take the square root of that variance, and you have calculated your standard deviation. Here is the formula for standard deviation, very similar to your variance, exactly like your variance, but then you have to add this square root. So it not too complicated. The square root of the sum of each score minus the mean squared divided by n. Simple enough. Should be pretty straightforward. Remember, S and sigma always are other symbols that can be used in addition to SD for standard deviation. Now there's a note right here, sample. Okay. A sample standard deviation, which is noted by S, the lowercase sigma, uppercase sigma is for the population. When we're dealing with a sample, which is a subset of the group you're interested in, instead of dividing by n, we divide by n minus 1. So if you had 100 people in your sample, you would divide not by 100, but by 99. And we'll get into the exact reasons for doing this a little bit later. It has to do with distributions of the population and extreme scores, and how with a sample you may not always get those extreme scores. And so it's just a better estimate of the variance or of the standard deviation. You use it in both variance and standard deviation. When you're calculating them with a sample, you are always going to divide by n minus 1 instead of n when calculating these measures of spread. So all right, so that looks like we've covered just about all we need to cover today. I suggest you go through the homework problems, work out a couple. If you need to rewind the tape, watch it a few times. Sometimes this information takes a little while to sink in. You might want to pause it on the formulas, write them down, really think about it. Statistics is something that you really need to conceptualize and think about to understand. So go ahead, go on, do your homework, rewind, watch again, and let me know if you have any questions. Thank you. Look forward to seeing you again.